a double pole switch, my top boss. As you can see from the front, you may just think that this is actually a one gang, but when we get to the back, things get very interesting. Now, so let us just unwrap it and explore the features in this important switch. Allow me to use those weird methods, all right? But we can simply, no, we have tools for a reason. So I can simply cut the wrapping like that. Here we have it. Look at that. Very important, right? So we have key features is that we have the L in and we have the N in this side, the lower side. We have the L out and we have the N out. Notice that this is like one line, this is another line. It's not like we have L and N, L and N, you know. So this is how the switch looks like from the front. Okay, and then from the back. So what is L in full meaning? L in. What does L in mean, my top boss? What does L out mean, and what does N in and N out mean? This is a very important switch in electrical installation. It finds its application especially in domestic wiring, single phase wiring. There are other applications as well in the industrial where we have to use some machines. You notice it is a 45 amperes, 250 volts. So this is a UK type switch, UK connection type. L in, why is the incoming power from below and the outgoing on the upper part? You know, those are some of the questions that I normally ask myself. Some of the items that are supplied, and we also have this, which is referred to as a cooker, cooker unit. Look at that. Cooker unit has another part which is a replica of the DP switch, like that. And then this part is basically like a single socket that you normally have in the house. So you have this part, you also have this part. And when you turn on the back, we also have this lower part as the incoming and this upper part as the outgoing. See, it is indicated out. UK. So in most cases, these switches and these electrical fittings are meant for UK, or they follow the UK standard. Okay. So now today we are discussing about the common mistakes when it comes to wiring the double pole switch, DP switch. So it's basically double pole switch. Thank you so much, my top boss, for tuning in. And if you will be watching on as a recorded version, thank you so much for clicking on this video. I really do appreciate. My name is John Gatehi and this is Top Heights Electricals and Electricians. So glad to have you. It is always a special moment when I interact with you, my top bosses. All right. Now, DP switch double pole. What does that mean on the, just by reading or hearing from the name? Double pole. It switches the line on face and it switches the line on the neutral. We say that electricity flows back and forth, you know, from the face all the way to the appliance or a device, and then it flows back. So back to the source. Let's say we are talking about a transformer through the meter board or through the consumer unit. It has to go through that path and then go back. All right. So when you switch both the neutral and the phase, definitely it means that that is breaking the circuit on both sides. So if you see this gang is too heavy, and as I said, it is a 45 ampere switch, so it can be able to handle the amount of current that flows. 45 amperes is a lot of current. When you compare, like say for instance, a switch that is one gang like this one, this is a light switch, and as the name suggests, it is very light and it switches only the phase. So there are differences between these two switches. If I may bring to your attention, we see that this is a light switch, a one gang switch, all right? And what is the specific name of this switch when you go to ask for it? There is something that I want to test if you know. Will you just say a one gang switch, light switch, or what other thing are you supposed to add there? From the look on the front, you can say it is a one gang light switch, but when you turn it, you can see that there is something that you can add to this switch as you are asking for, for the shopkeeper to give it to you, isn't it? Right? So these two switches are very different, and you have to note that. All right? You can see that this is a very heavy gun. It also has a red indicator there, or a red light. This definitely means that the switch is either on or off. Okay, so when it's on, this light will turn up, or it will light up, meaning that it is able to give an out. So it means that it has switched from the incoming to the outgoing, which is the L out and the N out. Okay, so it is on. But when it is off, this light will definitely be out, and the termination will only be limited to this position right here. Now, mistake number one that I have noticed with people is that there are loose connections whenever it comes to this switch. We say that it is a 45 ampere switch, and therefore it means that it conducts a lot or a heavy current. It sees it allows a heavy current switching through it, and you can even see the size, you know see that section, how larger it is, you know compared to what we have here for a light switch. It's not as big as that one, not as sophisticated, not even the screws. You notice that the screws on these light switch are very small as compared to what we have here. So when it comes to this switch, mistake number one is that people don't tighten those screws. If, for instance, someone is wiring a cable, let's go right into it. So let's say we have a 4.0 cable. So this is our cable. It's a 4.0. And in most cases, you find that this circuit usually is wired with a 4.0 or a 6.0 mm. That is the cross-sectional area of the cable or the conductor. So this is what we have. Okay. And also taking the face, which is in our case a red cable, this one here. Now we want to strip this cable. Another mistake that people make when using the cables for this specific switch, it could be applied in geysers, instant shower heads, and some heaters or even fans. Some people use it for fans. I saw another one use it for AC switching. So if that is the case, then it means that just by you having this cable, I mean this switch, does not mean that everything is okay. You have to ensure that even the cable itself is properly stripped. So we strip using this cable stripper. Why? So that you don't accidentally cut and reduce the cable strands. All right. I don't know whether it's clear. You don't reduce the cable strands. Very important point. Another important thing is that since this switch is big enough, and let me just unscrew it so that you can be able to see what I'm talking about. In fact, let me just show you the size of the screw itself. See, it's so big, and it can even allow you to screw it properly and see even the size of that part that is supposed to be screwed. It's quite big. Yeah. So if you don't tighten this screw, there is a problem with your work because it gives much allowance for that. So again, with this cable, this one is L in. So we have to use the red because it's a face. If you will just insert that cable, you find that it will go all in. But if someone screws and leaves these parts of the cable here, it is risky because if by accident it touches on that earth connection, and we know that this part here, the metallic part, goes all the way to the earth connection, it will short circuit, leading to a circuit breaker tripping, and so that circuit definitely will not have power supply because it has tripped. Okay, so what do we do? Myself, I will first of all, because there is sufficient space in there, I will simply backfold my cable. Okay, so by backfolding, I'm simply increasing the surface area or the area of contact. Simple. That is the simple reason behind backfolding, like that. Okay, and then I will insert it on L. See, again, another mistake that people make is to really insert it all in, such that when you will screw, you'll find that someone has screwed on the insulation. So that is very wrong. You ensure that you check on the screw and make sure that before you start screwing it, it is only in contact with the cables or the wires that you have stripped. If at all you press on this insulation here with that screw, there will be a strain in that circuit. But if you only screw on this part, it means that contact, the flow of current will not be compromised. So that is what we want to achieve. And this is exactly what I'm doing. I don't know whether you can see it clearly. Able to see that? Maybe you might not be able to see, but as you can see there is a screw and then the cables there just before the insulation. And then once we are sure about that, that is when we now go ahead and screw it. Again, we are using a screw driver, not a tester. Why is that point important? That point is very important because a screwdriver will ensure that you tighten. The mechanical grip will be very, very firm. So that is also mistake number 3. If you don't tighten these screws, it means that you will compromise the flow of electricity. And we say that electricity flows from the source to the appliance and then back, right? So we have tightened it, all right? And now we go to the end in. So you go step by step, and that ensures that everything is okay. Don't rush into anything, right? So we have our neutral. We are going to do the same. So we unscrew it. So make sure that the screw has been unscrewed all the way. Then with our neutral cable, you backfold it as well. So you have indicated, you insert it inside and ensure that the screw that is supposed to screw the wire is in contact with the wires only. Remember, the screw is part of the circuit. Why? Because it is in contact with the terminal that is actually connecting or looping the end out, so that the appliance that is connected to this switch gets enough current so that it can operate optimally. Okay, don't know whether that is the right word to use, but I hope you get my thinking behind it. Okay, so that is what we have. As you can notice, all the cables are all in. Okay, now when it comes to other connections, the L out, the N out, we do the same. When it comes to earthing connection, we also ensure that we screw all the earthing terminations, connections, the earthing cable. This is the color code for our earthing cable or our earthing connection here in Kenya. And I'm so sure in most parts of Africa. In the UK, they use brown, blue, and green with yellow stripes for earth connection. Let me know in your region, my top boys, what color codes do you use? Yeah, I have Morgan. Thank you so much for joining in. You say, do for me how to wire a changeover. Excellent request. I will definitely do that. And thank you so much, my top boss, Morgan. All right. So now that we have tackled about that connection, we have said that mistake number 1 is if you don't tighten these connections, especially the screws, that is a fault. If you leave cables or the wires exposed, they might short circuit. That is another bigger problem. And number 3, you say that if you screw on the insulation, it means that the appliance that is connected to this switch will strain to complete a circuit. If you understand about completing a circuit in electrical, it is very important. So if that is compromised, then it means that there's going to be a very big issue. Another thing that I've been noticing people do is using undergauged cables. So if you're supposed to use a 4 or a 6 mm cable and you go ahead and use a 2.5, there's a problem. Why? Because that particular circuit draws a lot of current, assuming it is a geyser, assuming it is an instant shower head. It means that it requires more current, and that cable that you use, which is a 2.5, will start overheating. Overheating is dangerous for electrical gears such as a DP switch. It will mean that that cable will start heating even the switch itself, be it a socket, be it a switch, any electrical fixture will definitely be compromised if at all that cable is heating. It is like taking a heating rod and just hitting on that switch, it will definitely compromise it. All right. So you have to be very, very keen on that. Another thing for that I've noticed also is that people short circuit the earth and the neutral in this DP switch. He said that short circuiting the earth and the neutral can lead to a phenomenon that is referred to as a bypass. You know, the today's smart meters or digital meters will indicate a bypass. A bypass means that you are drawing more electricity than it is supposed to. That will essentially translate to a customer paying higher electricity bills. So you're supposed to have the neutral and the earth connection clearly separated so that in the switch you have the earth connection as independent and as it should be. You have the neutral connection as independent as it should be, right? Just the way we have the neutral and the line or the neutral and the face very independent, very well separated, clear cut, we should also have that when it comes to the neutral as well as the earth connection. Isn't it, my top boss? Hmm. 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 Another mistake that I notice that people commit is that once one line fails, especially the neutral, right? They will connect, they will short circuit the neutral and only leave the switch to switch on the face. But you may ask me, John, but I think that is okay. No, 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 it is not okay. All right? Because assuming it is a heating system whereby people are in contact with the water and the likes, you expect that if you have switched everything, if you have switched the switch off, then you are supposed to switch the entire line as well as the neutral. Because if at all there is a leakage, then someone has to switch it off. And for instance, there's a leakage through the face, switching it off will definitely not do any help or any good because the neutral is already short circuited. All right. So what I actually mean is that you find that at this point, if this neutral line has an issue, someone will simply migrate the load from the out and then merge with the incoming neutral and connect it at this point. So that is what I'm saying, it is incorrect. All right. If this line has failed, just replace the entire switch, and that will save the customer on a lot, especially when it comes to paying heavy bills. All right. Yeah. So you will notice that compared to, there's also this switch that I also wanted us to talk about, this one, which also has that part for, it has this part for, what is it? For a double pole. So even this switch that switches actually on the, sorry about that, that switches on the cooker connector. This one activates the cooker connector down there or below there, or in some cases you find that the cooker connector is above it. So this is the cooker connector. The cable switch come from this part here, go to this cooker connector, and that is why we have that out. So the out will definitely feed the cooker connector. So with that, when we have this part which is a DP, we also find that people commit a lot of mistakes. And for this cooker unit, it performs a lot of functions, because at the point where we have the in, we also supply power to this single socket here. So the moment you feed this in, you are also feeding the out to the cooker connector, and you are also feeding this socket. So from that circuit, you have a lot of load. There is a bigger load there, because assuming that from the cooker connector, the cooker has been connected, and then another thing is that the home owner has connected something here, a home appliance. Let's say it is a heater, an electric kettle, or even a microwave. Some even connect freezers here, or even refrigerators. So that is a huge load. So if at all that wiring has been compromised, it is a loose connection. It means that there's going to be a very major problem with that double pole wiring. Okay, so we must ensure that we avoid these mistakes. Top bosses, avoid these simple errors. Loose connections, avoid exposing of the wires, which may lead to short circuits. Avoid screwing on the insulation. Avoid using lower gauge cables. Where you're supposed to use a 4.0, use a 4.0. And this goes for both the earth, the neutral, and even the phase connection. Also, when it comes to circuits which are even higher than the rating of the DP switch, for instance, where you're supposed to use a 6.0, ensure that you use the correct cable for earthing, for neutral, as well as for live, right? So thank you so much, my top boss. That has been my time. In the next video, what would you like me to talk about? Like my good friend Morgan has said, show us how to wire a changeover. Is it something that you are interested in? Definitely, Morgan has pinpointed that, and I will be honored to do it, my top boss. We have the automated changeover switching. We also have the manual changeover switching, whereby we connect the changeover switch manually. But we have another advanced one where we can command it through the use of an app, that is smart switching, where you find that if nobody is home, it's during the day, the load usage is very little, and the electricity, not the electricity, the national grid is off. Starting a generator at that point will definitely consume fuel for nothing, and the power that is being supplied is very minimal. So at that point, you can remotely, using your smartphone app, switch off or turn off that generator, and that is called smart switching. So we'll be talking about that in our coming videos. If it is something that you are interested in, my top boss, smash that like button. Just give this video a thumbs up, and I will know that that is what you're looking forward for us to do, my top boss. Also, if you have not subscribed, subscribe to our channel so that you don't miss this type of content if it is what you are interested in. Thank you so much, my top boss, for your time. I really, really do appreciate. That was my time. My name is John Gatehi, and this is Top Heights Electricals and Electricians. Goodbye for now.